We know that processor instructions are encoded in binary, but how? Let's find out. I designed my own CPU, cat processing unit, which processes commands for cats, like roll over, eat some amount of food, and get off the table. It also has built-in my cats, marshmallow, lexical cat, and milkshake, so you can build up commands like so.
Roll over. Roll over.
Now we need to encode this in binary somehow. We've got 3 types of commands, so we can use 2 bits to encode that. It's called the opcode, the kind of command it is. This actually gives us enough space for 4 commands, so if later we decide to add another command, then we could do so if we want to, say, tell our cats to become ungovernable. I have 3 cats, so another 2 bits for that. Then we need to represent the amount of food the cat should eat. For that I'll choose 4 bits, because that brings our instruction up to 8 bits in total. I implemented some programs to turn our textual commands into binary, visualize the binary, and run the code. So I can assemble the binary like this. I can visualize it like this. And now we can see we have our opcodes, which are 2 bits, and these encode whether we should roll over, eat food, or get off the table. Our cat is encoded in 2 bits, which tells us which cat it is, and our operand is ignored for rolling over and for getting off the table, but for eating food, it tells us how much food we should eat. And this is essentially what real processors do. All our instructions are fixed to 8 bits. Some processors like MIPS 32 chips are fixed to 32 bits. Some like x64 are variable size. Their instructions are between 1 byte and 15 bytes. Let's have a look at MIPS in more detail. I wrote an instruction visualizer for MIPS, and you can see it's pretty similar to our cat example. We've got a few different formats of instructions, like J instructions, which are jumps. They have an opcode, the kind of jump it is, and the address to jump to. We've got I instructions, which take immediate values, so we can add a certain number to some register. And then we've got R instructions up here, which operate on registers and have lots of different operations they can do based on this funced secondary opcode. And that is how instructions to your processor are expressed in binary.